We shall study about the derivation of Born Lande's equation. Born Lande's equation. So, how to derive this equation? We know that ionic lattice is modeled as an assembly of hard elastic spheres which are compressed together by the mutual attraction of the electrostatic charges on the ions. So, considering the ionic lattice to be composed of ions having opposite charges, suppose it is positive charge and here it is the negative charge. So, there is mutual attraction of the electrostatic nature due to the opposite charges. There is always an attractive force acting and they achieve the observed equilibrium distance. Now, how if attractive force is operating among these two ions, up to how much distance should they come together? Should they come closer? That is to be considered. So now there is a distance of closest approach up to which these ions can come together, come close together. So they achieve the observed, that is called the equilibrium distance. Equilibrium distance. Now there is a balancing short range repulsion also taking place. When they come up to a certain point, then there is repulsive force operating. And this is the short range. This force is of short range. So they come closer up to a certain distance that we indicate by R naught. And whatever is the distance between these two ions, that you can say that this is R. And at the distance of closest approach, this separation between the two ions is represented by R naught. So let us see how the electrostatic potential is operating. So the electrostatic potential, which is denoted by E pair, it is the equal and opposite charges. It is operating between the equal and opposite charges, and that is equal. That is the attractive. That is due to the attraction between the ions, and this potential is represented by the equation E pair is equal to minus z square E square divided by 4 pi epsilon naught R. This is the equation for potential between the electrostatic potential between the two ions. And there is negative charge, it means that the force is attractive. Now, here we will explain all the terms where Z is the magnitude of the charge on one ion. And E is the elementary charge, that is charge which is present on one electron, that is 1.6 into 10 power minus 19 coulomb. Equal to 1.6022 into 10 to the power minus 19 coulomb. Epsilon naught, as we all know, it is the permittivity of the free space. Free space. And 4 pi epsilon naught, the value of 4 pi epsilon naught, that is equal to 1.112 into 10 to the power minus 10 coulomb square joule meter. R is the distance separating the ion centers. Here, this is the distance between the center of ion. This can be represented as R. And when R becomes R naught, then this is the equilibrium distance between the two ions. So for a single lattice consisting of ions with equal and opposite charges in a 1:1 ratio, means the ratio between the number of positive ions and the number of negative ions is 1:1. Then there is interaction between one ion and suppose it is positive ion. It is interacting with all other lattice ions. So that is interaction is needed to be summed up considering one ion. All the neighboring ions surrounding it are to be taken into consideration. So there is interaction between this ion and this neighboring ion, this ion and this neighboring ion, and so on. That is to be summed up to see the overall interaction. And EM is calculated. It is sometimes called the Mandelung's or the lattice energy. Mandelung energy or the lattice energy. Now, we can represent it by the equation EM is equal to minus Z square E square M divided by 4 pi epsilon naught R. Here we can see that the previous equation E pair is equal to minus Z square E square by 4 pi epsilon naught is multiplied by M, which is the said to be the Mendelung's constant, and that is the lattice energy. Now it becomes the lattice energy when you multiply this equation by M. So here M is the Mendelung constant, and this is related to the geometry of the crystal. Means depending on the geometry of the crystal, Mendelung constant will also change. It is different from for different crystals and same for crystals having the same geometry. Now, what is repulsive term? I have said earlier that at some short distance of the closest approach, there is repulsive force operating between the ions. So let us find out what is the repulsive term of the potential energy. Now, this term was suggested by Born and Long. They suggested that A repulsive interaction between the lattice ions would be proportional to R to the power n. So, ER, if I say that this is the repulsive energy term, then this is equal to B divided by R to the power n, where B is the constant scaling the strength of the repulsive interaction. That is, B is a constant dependent on the or scaling the strength of the repulsive interaction. Interaction. R is the distance between the two ions of the opposite charge. And Bond said that this is the closest distance between two ions of opposite charge. And n is here, this exponent n, that is equal to the said to be the Born exponent. Number between 5 and 5 to 10, 12. 5 to 12. Number ranging from 5 to 12. It can have many values ranging from 5 to 12. Total energy. Total energy can be found out by summing these two terms, electrostatic term and the repulsive term. Now, minimizing the energy with respect to R yields the equilibrium separation R naught in terms of the unknown constant B. Means if we have to find out the distance of closest approach or the equilibrium distance separation R naught. So to find out the value of R naught, we have to minimize the energy because at the distance of closest approach, the energy is minimized. So differentiating the above equation with respect to R, what we get? dE upon dR is equal to minus Z square E square M divided by 4 pi epsilon naught. Here R to the power minus 1. So minus 1 into minus 1 according to the rules of differentiation, plus minus n into b into R to the power minus n minus 1. So that becomes equal to Z square E square M divided by 4 pi epsilon naught R square minus nb R to the power n plus 1. So putting this, when dE by dR becomes equal to 0 at the distance of closest approach. So we should write it afterwards. First of all, I am writing it as dE by dR only. We have dE by dR. And I am writing again that at R is equal to R naught. dE by dR is equal to 0. Now putting these values in the above equation, What we get? 0 is equal to minus z square e square m divided by 4 pi epsilon naught r naught square minus nb r naught to the power n plus 1. So from this equation, we get that r naught to the power n plus 1 is equal to 4 pi epsilon naught n d r naught square divided by z square v square m. From this above equation, solving this equation, we will get this. Then from this equation, we can find out the value of b, that is the repulsive term constant, which we have to find out. Now b is equal to z square e square m r naught to the power n plus 1 divided by 4 pi epsilon naught n r naught square. Now this is equation number 1 and this is equation number 2. From 1 and 2, from equation 1 and 2, putting the value of b in equation number 1. Not in 1, this is not equation number 1. We will put this value in equation number. Earlier we had this equation, ER is equal to, this is 1. So what we get, if we put this value of b, we get that ER, the equation was what? ER is equal to minus z square e square m by 4 pi epsilon naught r plus b upon r to the power n. Now, if we put the value of b in this equation and putting r is equal to r naught at r is equal to r naught, this energy E r naught is equal to minus z square e square m divided by 4 pi epsilon naught r naught plus z square e square m r naught to the power n plus 1 divided by 4 pi epsilon naught n r naught square r to the power n. Now solving this equation, what I get? Minus z square e square m divided by 4 pi epsilon naught r naught into 1 minus r naught to the power n plus 1 r naught divided by n r naught to the power n plus 2. Again, solving again, what I get? Minus z square e square m divided by 4 pi epsilon naught r naught into 1 minus r naught to the power n plus 2 by n r naught to the power n plus 2 Now this cancels out. R naught upon plus 2, M naught upon plus 2. So what I get? Minus Z square E square M divided by 4 pi epsilon naught R naught 1 minus 1 by N. This is the equation for the Born Lande equation. Thank you.